All right, let's take a look at homework 8. This is on the test of hypothesis for a single sample. Question 1. Sears uses millions of batteries each year for its surveillance cameras. The brand of battery it currently uses has a mean life of 400 hours. Competitor claims that its batteries, which cost the same as brand Sears currently uses, have a mean lifetime of more than 400 hours. More than. Sears has decided to purchase the new brand if, when tested, the evidence supports the manufacturer's claim at 0.05 significance level. Suppose 49 batteries were tested with the following results. X bar equals 417.5 hours, S is 60 hours, and conduct the test using alpha is 0.05. Remember, alpha and the significance level are the same thing. So the null and alternative hypothesis, first of all, we're dealing with a mean. So we're going to deal with mu as the parameter. So our null hypothesis is that the mean equals 400. We use equal to sign for the null, and the alternative we use either doesn't equal, less than, or greater than based upon what the test is indicating, what our claim is. Our claim is more than 400. So our alternative, HA, is that the mean is greater than 400. All right, what test are you going to use? Well, let's look at the conditions for the test first. So first of all, we're dealing with quantitative data. Since we used a mean, since we're using mu, so that one's good. And the next thing we have to determine is whether the sample size is large enough. So for n to be large enough, we need n greater than or equal to 30. Well, we have n as 49. That is certainly at least 30, so this one's good. That means we're going to use the z distribution because we have a large sample. If it were a small sample, we would use the t distribution. So this will be a z test. That's what we use in the calculator. Okay. Let me see if okay, so let's do this one. We'll make sure we keep this information on here. Show the formula without numbers and the formula set up with numbers to compute the test. So the test statistic, that should be on the upper thing, but something got messed up in formatting. All right, so the test, we're going to use the z distribution, so z test. If you want to just say z, that's fine. Well, that's x bar minus the mean. So that mu sub 0, is the proposed. So recall, HO is the mean equals mu sub 0, mu naught. So it's going to be that 400 is what we're going to be using there. We don't have sigma, but we do have S. This is going to be S over root N. So X bar is given as 417.5. That's given right here. S is 60. N is 49, excuse me. That's N. So root 49. And then our mu sub naught, as I mentioned earlier, was 400. So that's what it is going to be. When we run the test, we'll come up with a number and we'll put it over there. We don't need the number to answer this question, though. All right, compute the p-value for the test and round to 4 decimal places. Use the calculator function that we listed in part 2, and that was the z-test. So let's do that. So stat and go over to tests will get us to it. Z-test is the first one. All right, we do have summary stats. We're going to leave that there. If you have data highlighted, make sure you arrow over to stats and hit enter. Mu sub 0, our proposed value is 400. Sigma, we don't have sigma, but we do have S, and that's 60. X bar is 417.5. and n is 49. Now, the choice here is very important because this choice will dictate what your p-value is. The test statistic will remain the same regardless of your choice for the alternative, but the p-value is conducted based upon what sort of test. We actually have the correct one. It's the third one. And now we're going to hit calculate. So we don't need to answer this in part 3 because it wasn't required, but note that the z-test equals this 2.04. That's what we see right there as the z. So the p-value is what stated as p there, so our p-value equals 0.0206 if we're rounding to 4. All right, now list a conclusion. It mentions that something that doesn't have any symbols in it. I don't care about that so much. As long as you put it in context, you should be fine. We can do the symbols up here. So based on the p-value, we reject HO because our p-value is 0.0206, which is less than or equal to 0.05, which is alpha. Now, to state that in context would be we have significant evidence to conclude that the new brand of light bulb will last longer. And we'll just say longer than the old ones or longer than 400 hours. How's that? Now, yours doesn't have to be verbatim the same as mine, but make sure that you're saying a similar thing. We have evidence to say that the new light bulbs are better, last longer, something like that. All right? That would be in context of the problem. So in problem 1 and in problem 2, I've laid out each of the individual things you're supposed to do for a test. In the later questions, I just say, hey, do the test, essentially. That would be question 3, conduct the test of hypothesis, that sort of thing. But let's go and do number 2. All right, so number 2 says a repair shop advertises that the average time it takes them to complete an oil change is under 15 minutes. So let's highlight that again. Under 15 minutes. Sample of 100 oil changes are recorded in order to determine if the claim is true. Sample mean was 14 and the sample standard deviation was 5. Conduct a test at a significance level of 0.05. So let's just write down some of the things we know. First of all, n equals 100. That's this guy here. That's this 100. Sample size of 100. X bar, sample mean, is 14. We don't have sigma, but we do have S. S is a sample mean, and that is 5. And finally, our significance level is alpha, so that's 0.05. Those are the things we need to know in order to do this. So list the null and alternative. Again, HO. We're going to deal with the mean. The mean equals, well, 15 was our default time, so let's go with 15 minutes. You can write minutes. And our alternative is under, which is less than. So mu is less than 15 minutes. All right, what test are we going to use? Well, let's do the conditions again. Well, we know it's quantitative again. Since we have mu, or have x bar, I guess, that'll work. We're good. And the next thing was check n. N for size. So we have n is 100, that is greater than or equal to 30, so we go with the z. So we're going to use a z-test. So the formula will be the same. And actually the formula is the same whether it's a Z or a T for this case. So there it is. Our X bar is 14. Our mu sub 0 is 15. That's our proposed value. S is 5 and N is 100, so root 100. And we'll calculate that with the calculator as well. We don't need to do all that by hand. All right, so compute the B value. Let's do this again. Stat tests, Z test. All right, we're testing at 15. That's our mu sub 0. We don't have sigma again, but we have S, which is 5. X bar is 14, and N is 100. We do have to change this next one, so we'll arrow over to the less than mu 0 and hit enter. Now we have that toggled, we'll be good. So here we have Z test. Is equal to just straight up -2. Okay. All right. The next thing we have is the p-value. That's 0.0228. Pardon that. And finally, in this we know is also less than our alpha, which is 0.05. So we're going to reject again. And if we put this into the context of the problems, what did we have? Less than 15 minutes for an oil change? All right. So we have evidence to indicate, or sufficient evidence to show that the oil change is indeed under 15 minutes. Something like that. Now, if you're not going to state the conclusion above here, up here, then state it in your conclusion as well, because our p-value is less than our significance level, we reject, that sort of thing. Okay. Now, again, number 3 and number 4, I didn't give you the breakdown of everything, but I did post sort of the bare minimum you're going to need to do these things. So let's take a look at this first one. An appliance company advertises that its brand of washing machine will last a lifetime. Well, not really a lifetime, but longer than 10 years. A random sample of 50 machines manufactured in the past 20 years is selected to test this claim at a significance level of 0.1. If the sample mean is 11 years and the sample standard deviation is 4, conduct the test of hypothesis. So let's see what we can unpack with this. So first of all, random sample of 50 machines. So this means n equals 50. Okay. The next piece. Significance level of 0.1. That means alpha equals 0.1. Sample mean is 11 years. That means X bar equals 11. And finally, the sample standard deviation is 4. That means S equals 4. So these are the summary statistics that we have. We're dealing with X bar. That means we're using a mean. So we're going to use mu for the parameter. So now we're going to try to calculate what our null and alternative hypothesis is. We're looking for longer than 10 years. So our null hypothesis is the mean is equal to 10. Our alternative is that the mean is greater than 10 because longer means larger than. All right, so which test are we going to use? Well, our n is equal to 50. That's at least 30. So we're going to use the z-test. All right, so let's go and do it doesn't ask us to give us the formula. We're going to use the z-test. I'm going to choose the p-value method because it's quick and easy. So stat, tests, same test we did for the other two. Mu sub 0 is 10 in this case. We don't have sigma again, but we have s is 4. X bar is 11. And n is 50. Larger than 30, so we're good. We're looking for greater than, so let's go change it back to greater than. And calculate. Our p-value is 0.03. What do we want? 4 decimal places before, so let's try to keep that up. 38685. Excuse me. Well, that's certainly less than or equal to 0.1, which is our alpha, so we reject HO. Now, it doesn't actually tell us to specify this in context. So this could be like the bare minimum for the actual question. I'm going to write an extra thing and say, there is evidence to back up their claim. Note that wasn't in context either. So if I needed to use it in context, I would have to say something along the lines of, we have evidence to indicate that the, washing machines do in fact last longer than 10 years. All right, and finally, number 4, a school states that over 85% of its graduates find employment within the first year after graduating. Recent sample of 400 graduates. 400 graduates, this is going to be N. Was selected at random, I guess maybe were should be there, but anyway, and asked the questions, did you find employment within the first year after graduating? All right, 348 of them responded yes. This is going to be the letter X. So this is X equals 348. Remember, this is the number successful. P hat is equal to X over N. All right, anyway, test the claim at 0.05. All right, so over 85% means we're looking for larger than, so our null is P, so parameter P, because we're dealing with qualitative, is going to equal 0.85 versus our alternative, P is greater than 0.85. Now, we should really check to see if we can even run this. So, is N large enough? Well, I mean, you can simply look at X and 1 minus X, or N times P hat, or N times 1 minus P hat. So N times P hat is going to be 400 times 0.85, and that comes out to 340, which is at least 15. And now 340 is a good proportion of 400. If this was a lower proportion, I could probably just be done there and use the lower one. So we'll use N times Q hat. Q is again 1 minus P. 400 times 0.15 is going to equal 60. That's also 15, so large enough. So we're going to use the one prop Z test. All right, so let's do that. Stat tests. One prop Z test is number 5 there. We'll go to that. So P sub 0, again, is our proposed value. That's going to be this 0.85. That's P0, P sub 0. Well, it looks like I have the stuff already in. X is 348, N is 400, and we are in fact doing greater than, so we calculate. Please note there are two letter P's there. We have a P for p-value and a p hat, which actually gives us what the proportion is x over n. So that, excuse me. So this is equal to x was what, 340? So that apparently came out to 0.87. All right, at any rate, our p-value was equal to 0.1313. Well, what was our alpha? Our alpha was, I didn't write it down. Alpha is 0.05. Okay, so we're going to compare that to alpha. Excuse me, it is not less than, it is greater than. And that means we fail to reject HO. Remember, we never, ever, ever just write the word except. We haven't proven that the null is correct. We just don't have evidence to indicate that it's wrong. So we have evidence, we don't have evidence to support the claim. And if I want to write it in context, let's do that. Claim that over 80% of the graduates find employment. And is it just employment or within a certain time? Within the first year of the graduates find employment within the first year after graduating. And again, I didn't ask for context here, but this is context in the event that the question does ask for it. So this is hypothesis testing for one sample. There was at least one proportion in there. Most of them were the mean, but that's how we do it.